again. Here is a probability question. Question 42 from the 2013 exam, and like with all questions, you have to read it very carefully. So here we go. In a particular version of roulette, a ball randomly stops on one of 38 numbered pockets. Okay, each one then has a probability of 1 in 38 of the ball landing there. If you bet on the number of the ball lands, you get 36 times what you bet. Okay. One tactic I use to bet the same amount for 35 games in a row. Okay, we're doing this 35 times. N is 35. Determine the probability that a gambler makes a profit using this tactic. Okay, you play for 35 times. You get 36 times what you bet if you win. So if you win once, well, you're a winner, or twice, but at least one. You only got to win once to be a winner, and all the rest every other time you win lots. The only time you lose is if you don't get a win at all. Okay. Determine the probability. Well, you have to recognize that this is a binomial distribution problem. It's binomial because you either win or you don't, and your ball comes up or it doesn't. You've only got two options, and that's what makes it a binomial situation. So once you realize that you win or you don't, then we can start writing down the numbers we've got. So we're doing this 35 times, because we're told to play 35 games. The probability of success, 38 pockets, is 1 out of 38. And then turn the probability to make a profit. For a profit, you need 1 or more win. Okay, now we have to set up the equation that it is that we have to use to do this. When you need 1 or more, if you remember a probability distribution table, here's your x and here's your probabilities. 0, you can either win 0 times, 1 time, 2 times, all the way up to 35 times if you do this. All the probabilities massed up to 1, because one of those things is bound to happen. We're actually interested in needing 1 or more, so we're interested in the probabilities of this lot. That is 1 minus the probability of getting 0, because they all add up to 1, and there's a probability of it. And it's that idea that we're going to use here. Sometimes you might have seen the words you need probability of at least 1 would be another way of saying you saying 1 or more profit. You need at least 1 win. Okay, so we need probability of at least 1 win is equal to 1 minus the probability of no wins. Now we can use the binomial distribution probability equation, p to the x 1 minus p to the n minus x. There's the equation. Let's just put in the ones now. When we have 0, so this time we're interested in x equal to 0 to use this. Probably at least 1 win is equal to 1 minus n is 35. 0. P is 1 over 38. That's to the 0. And 1 minus P is 1 minus 1 over 38, or 37 over 38. N minus x is 35 minus 0, which is just 35. And that comes to 1 minus, that's just 1, that's just 1, and that is 37 over 38 to the power 35. So it's 1 minus 37 over 38 to the power 35. So I'll just do that on the calculator. Over here we got 1 minus 37 divided by 38, close the bracket, all to the power 35, and it's that. And again, of course, read the question carefully. Up here it says to three decimal places, so that comes to 0.607 to 3 decimal places, because the fourth decimal place is a 7. Okay, so the probability of profit equals 0.607. Okay, you needed to recognise it was a binomial expansion, and you needed to use the probability of at least one win is 1 minus probability of no wins, and that's that.